there are two geometric progression. We have two GP here, GPA and GPB. The first term of A is 8. Okay, let me write this. We have two geometric progression. So this is geometric progression A, and we have another geometric progression B. The first term of A is 8. So the T1 is 8 for geometric progression A. And the first term of B is 4. Both progression have the same sum to infinity. So sum to infinity, I just let it be K. Sum to infinity, K. Okay, why? Because they are equal to each other. Both progression have the same sum to infinity. The sum of the third terms of A and the third term of B is equal to 9 over 4. Okay, so here we have common ratio, here we have another common ratio, right? So I just write this, I just use RA to represent the common ratio of GPA. So RB to represent the common ratio of GPB. Third term, the sum of the third term of A and the third term of B is equal to this. So from here, the third term will be A times R n minus 1, right? Still remember the formula? A R n minus 1. Now I'm using this formula. So it will be 3 minus 1, which is equal to 2. So how about this? First term is 4. Okay, 3 minus 1, you get 2. So we know that these two add up together is equal to 9 over 4, which is given by the quotients. So 8 times R 2. Okay, this is a common ratio for GPA. This is a common ratio for GPB. It's equal to 9 over 4. Now let me multiply the whole equation by 4 so that I don't have fraction here. Easier for me to continue doing it. So here you get R squared. So here also R squared, but be careful, this R and this R are different. So here you will get 9. Okay, let this one be the first equation. The 10 terms for the GPA is negative. Negative. Okay, so now we have, you can just assume that this is X, this is Y. So now we have two unknown. How do we get the value of these two unknown? We need another equation, right? So still remember this one, just now the question told us that their sum to infinity are the same. Now the sum to infinity of this one, what is the formula for sum to infinity? A over 1 minus R, right? Okay, so the sum to infinity for this one will be A, which is 8, 1 minus R, 1 minus RA. So this is a common ratio for the GPA. How about the sum to infinity of GPB? Using the same formula for 1 minus R, and this is a common ratio for GPB. Okay, what the question is actually want us to do is, a student state that the sum of the first 4 terms, the sum of the first 4 terms of A is larger than the sum of the first 4 terms of B. So is the statement correct? Give your justification. So what I'm going to do now is to find the common ratio and the first term I don't have to find already given by the questions. What do I need to do is to find the common ratio for each GP. And then what I'm going to do next is to find the sum of the first four terms for GPA and the sum of the first four terms of GPB. And then I compare these two, see which one is larger. And a student state that S4 for GPA is larger than S4 for GPB. I want to test whether the statement is correct or not. So I'm going to find S4 for A and S4 for B, and then I'm going to compare. So I know, so that I can determine whether the given statement is correct or not. Now, to find the value of the common ratio for both GP, I'm going to rearrange this to have to form another equation. So do cross multiplication. Just do some expansion. Okay. 8 minus 4 is equal to negative 4 times RA plus 8 times RB. Okay, so 8RB minus 4RA is equal to 4. So I'm going to reduce it, divided the whole equation by 4, so make the number smaller, easier for me to continue doing it. Oh, divided by 4, faster. Okay, so RA is actually equal to 2RB minus 1. Now, let this one be the second equation. So now I can solve them simultaneously to find the value of the common ratio for the GPA and the common ratio for GPB. Substitute the second equation into the first equation. So 32 times base 1, RA is equal to this, right? 2RB minus 1. Don't forget to square it. Plus 16 times RB squared is equal to 9. Now we only have one unknown. We can find the value of this unknown first. Do expansion for this one. 4RB squared minus 4RB plus 1. So I'm using this formula. A minus B squared is equal to A squared minus 2AB plus B squared. This you learn in Form 2, right? Okay, this one just copy first. Do some expansion over here. Minus 9 is equal to 0. So let me simplify this. 128 plus 16. So I will get 1, this is 4, 4, 1, 144, right? 144. Okay, this one just copy. And this is 23. Is equal to 0. Okay, so next I'm going, the number is a little bit large, so I am going to use calculator to help me to do the factorization. 144, negative 128, 23. Okay. So my calculator show me this answer, 23 over 36. And another one is 1 over 4. but you cannot from here just skip to the final answer. You need to show this factorization step. Okay, how to write the parentheses for this one? I mean the term inside the parentheses. So whenever you see a fraction, you leave some space. Leave some space here. Okay, if you get positive, you are going to write negative. Just write negative minus 23. So the 36 is over here. Okay, do the same thing. So this is fraction as well. I'm going to leave some space here. Positive, I'm going to write negative 1. And this is 4. Okay, so 36 times r minus 23 is equal to 0, or 4 times r minus 1 is equal to 0. So r is equal to 23 over 36. How about this one? It's equal to 1 over 4. So which one is actually correct? We need to refer to this. So the question tells us that the T10 for geometry progression A is less than 0. So I'm going to use this both to help me to get the common ratio for geometry A first. So the RA is equal to 2 times this. Two times 23 over 36 minus 1. Okay, just press your calculator. You will get 5 over 18. 5 over 18, yes. How about this? Two times this minus 1. So this is negative 1 over 2. Now I have two pairs. So how do I determine which one is actually the pair that we want? Now, go back to this. T10 is less than 0. So T10 is less than 0. T10 is, this is AP, right? A plus n minus 1 times d. The d is, oh, sorry. I use the wrong formula because this is GP. I need to use GP formula. A R power n minus 1. So 10 minus 1 you will get 9 less than 0. So divided it both sides. So R power 9 is less than 0. And R is actually less than 0, right? So we know that we want the common ratio for geometry progression A less than 0. So this will be the pair that we are looking for, right? So we know that, therefore, the common ratio for geometry progression B is equal to 1 over 4. And the common ratio of geometry progression A is equal to negative 1 over 2. So these two, we just ignore them, not accepted. Now what I'm going to do next is to find the sum of the first 4 terms for geometry progression A and geometry progression B. So this is A. This is B. Okay. So sum to the first 4 terms of geometric A. Okay, let me represent it this way. What is the formula? Sn A 1 minus Rn over 1 minus R, right? So the A is equal to 8. 1 minus R. So r is negative 1 over 2, which means negative 0.5, negative 0.5 to the power 4. Okay, over 1 minus r, so negative 0.5. Just press your calculator. So here you will get 5. So how about this one? Using the same formula, sum of the first 4 terms of geometric progression B is equal to, okay, the first term is 4, right? 4. 1 minus r. So this is 1 over 4. You can write 1 over 4, or if you don't want, you can just change it to a decimal, which is 0.25. 0.25 power 4. 1 minus r. Okay. Okay, here you get 5.3125. So from here, when you compare these two, you know that sum of the first 4 terms of geometric progression B is actually larger than the sum of the first 4 terms of the geometric progression A. Now let's go back to the given statement. A student state that the sum of the first 4 terms of geometric progression A is larger. Oh, so we can make a conclusion that the statement is incorrect. Therefore, the given statement is false. Okay, maybe I change this to, I add the word seen. Since sum of the first 4 terms of the geometric progression B is greater than sum of the first 4 terms of the geometric progression A. Okay, therefore the given statement is false. Okay, so this is a way how do we solve this type of question. That's all for this video. See you in the next video. Bye bye.